Okay, today we're going to do an introduction on, first of all, kind of conics. We're going to be talking about conics in this chapter 10. And there's four different kinds of conics. One is a circle. And you can kind of see here, if you take a cone, and that's where conics come from, and do a horizontal cut through it, you're going to get a circle. All right, so you can kind of see here from this picture, what you see is a circle. Same cone, and if instead of a horizontal cut, you do a cut that's at an angle, and it's kind of like a slant that we just dealt with, you're going to get an ellipse. If you get a cut that kind of cuts has a steeper slope, you actually get a parabola. So if it goes through the base of it, you're going to get a parabola here. And then if you get a cut, and I'm going to show you, you kind of have a cone on top of a cone. Let me show you that example. I had to talk about the cone heads there. Sorry. You're going to get a hyperbola. And so this here shows us a hyperbola where we have two cuts. An hyperbola is kind of like a parabola on top of a parabola. All right. And so we have different ways we can look at cones. I'll also put on the website a video that you can watch as well that kind of shows how cones, kind of more in animation, how cones can be cut. Before we can look at the first cone that we need to talk about, which is circles, we need to work on completing the square. It's kind of like a skill that we need to do to work on the circle equation. And so we're going to talk about how do we complete the square? How do we develop a flair for completing the square? And it's just a process. It's very sequential, very linear. So hopefully if you like sequential types of work or linear types of work, you're going to be fine with this. So what you do is you start by looking at your constants and you say, I need to move my constants to the right side of the equation. So there's the 7, and to move it to the right side of the equation, I would subtract 7 from both sides. So that kind of shows here that I subtract 7. Then we're going to take half of the coefficient of x. So my coefficient of x here is the negative 12. Half of that would be negative 6. Okay? You take this negative 6 and you square it. Negative 6 squared is 36. And then you're going to add that squared value to both sides. So you can see here what I did is I added 36 to the right side and to the left side. Well, on the right side, negative 11 plus 36 is 25. On the left side, what we can do is we can factor this. We can kind of say to ourselves, what two values multiply to give me 36? And when I add them, it's going to be negative 12. And the answer is you kind of have this x minus 6 and a minus 6, x minus 6. Well, that turns out to be x minus 6 squared. Well, a quick way to think about this, or to kind of work this out, is that will always be half. Kind of this is always what we'll start with, is always what you're going to get here in the grouping with what's squared. The x minus 6 is squared, so that equals 25. So then we need to solve it. In order to solve it, what we're going to do is you take the square root of both sides. Okay? So when we take the square root of both sides, what we have is on this side, we'd have x minus 6 equals, and what happens is you either get a positive 5 or a negative 5, because when we take a square root, your answer is plus or minus. So here x minus 5 equals a positive 5, and then if I add 6 to both sides, I get the x equal 11. Here, if I add 6 to both sides, I get x equal 1. So my answers were positive 11 and positive 1. And later on, you're going to see where we use that. For today, that's just where we're going to stop. So we're only focusing on how do we complete the square. So you should have this assignment. It is completing the square worksheet. I think it says at the top, I'm thinking 10.1. But let's just go through a few of them. Let's start here with number 1. Our first step is to put the constant, if you do have one, to bring it over to the right side of your equation. Then our second step is to say to yourself, what's half of your coefficient of your x? In this case, it's going to be 3. And you square it, and that's what you add to both sides. So here I have x squared plus 6x, and then over here I had 6. And what I'm going to add to both sides is I'm going to add a 9 to both sides. So now my problem becomes on this side. Here, I have 15. On this side, it has to be something squared equals that 15. Well, it's always going to be half of your original coefficient of your x. So here it's x plus 3. If this would have been a minus here, it would have been x minus 3. Now my setup is that I'm going to want to take the square root of both sides. So when I take the square root of both sides, I need more space here, sorry. I'm getting x plus 3 equals plus or minus the square root of 15. Well, square root of 15 does not have a nice answer. It's a decimal answer. So I'm going to just leave it as square root of 15, and I'm just going to write it as negative 3 plus or minus the square root of 15. Let me do another one for you. Actually, I'm going to do number 4 here, because number 4 is a good example. So let's do number 4. So now, with number 4, my first step, would be, again, bring the constant to the right side. So x squared minus 7x equals, I'm going to bring the constant, it'd be 21 now. So now I need to take half of my coefficient of my x. Well, the coefficient of my x is a negative 7 halves. Half of that, or negative 7x, half of that would be negative 3.5. And then I need to square it. Okay? So what I need to add to both sides is 12.25. What negative 3.5 is squared. Whoops, 25. All right. So here, what's squared would be x minus 3.5. Here, 21 plus 12.25 turns out to be 33.25. When I take the square root of both sides, I get x minus 3.5 equals plus minus the square root of 33.25. Solving it for x would be 3.5 plus or minus the square root of 33.25. Okay, now let's do another example. I want to do problem number 7 now. So let's look here at problem number 7. I kind of move it here. 7 is unique in that it's our first problem where we have a coefficient that's not a 1. And in order for completing the square to work, you have to have a coefficient that's not a 1. So I'm going to divide everything here by a 2. So you're going to divide it by whatever gives you a coefficient of 1. So now I have x squared plus 12x plus 12.5 equals 5. We kind of have to work to make fractions or decimals our friends. So we need to bring that to the other side. So I'm going to subtract 12.5 on my right side. And so now I'm going to have x squared plus 12x, I'm going to leave a space, equals negative 7.5. So now I'm going to say to myself, well, what's half of my coefficient of my x, which is 6, and when I square it, it's 36. So I'm going to add 36 to both sides. Over here, I get 28.5. Here, I have to think to myself, what would be squared? It's going to turn out to be 6. Remember, it's back to half of that. So then, when I take the square root of both sides, I'm going to get that x plus 6 equals plus or minus the square root of 28.5, which means that x would equal negative 6 plus or minus the square root of 28.5. And remember, that's my two solutions. Let's go through another one here. I actually want to go through problem number 8. I'm going to actually move this over a little bit so we can kind of have 8 here. All right. First step, get rid of your denominator, or make it a leading coefficient of 1. So I'm going to divide everything by 7. So when I do that, I get x squared plus 4x here plus 8 equals 0. Bring over my 8 to the other side. X squared plus 4x equals a negative 8. Now I'm going to take half of the 4, and then that's 2, square it, and I'm going to be adding, oh, sorry, not 2. I said 2, and it got in my head, plus 4 to both sides. So I'm adding 4 to both sides, and now I have the absolute value, or the square of x plus 2 equals a negative 4. Now this is where we have a problem with this particular question, because you can't take the square of something here and have it equal to a negative. So this one is actually not possible. You could say there's no solution. you can say this solution does not exist. There's a lot of ways to say, nope, it's not going to work out for this problem. So that one's actually not possible to solve. It's an impossible problem. And I just want you to complete the worksheet. There was 12 questions on this worksheet, and I just want you to go through all 12 of them. Good luck. I gotta see here.